So for polynomial division, we could either do long division or synthetic division. I'm going to do synthetic division. So remember, the input is the root of the divisor. So if the factor is x minus 2, the input is positive 2 because 2 minus 2 is 0. And then we take the coefficients of each power. So 5 from the x cubed, negative 1 from the x squared, positive 4 from the x to the first power, and negative 3 from the constant. Okay, so we bring the first number down. 2 times 5 is 10. Negative 1 plus 10 is 9. 2 times 9 is 18. 4 plus 18 is 22. 2 times 22 is 44. Negative 3 times, plus 44 is 41. Okay, and then remember that this is always the remainder. This is the constant. So this becomes x to the first power. This would be x squared. Okay, so putting it all together, we have 5x squared, and then positive, so plus 9x, and then positive 22, so plus 22. And then for our remainder, we put it over the factor we divided by. So that is choice D. Possible rational zeros. So we use the rational root theorem. So P is all the factors of the constant. So plus or minus 1, plus or minus 2, plus or minus 4. And then Q is all the factors of the leading coefficient. So plus or minus 1 and plus or minus 5. And then now we need to make all possible fractions using one of the P values and one of the Q values. Oops, 5. Okay, so we could do all of these over 1. So 1 over 1 is 1, 2 over 2 is 2, 4 over 1, or 2 over 1 is 2, 4 over 1 is 4, and we can do both positive and negatives. And now we can use all of these numerators over a denominator of 5 instead. So plus or minus 1/5, plus or minus 2/5, plus or minus 4/5. So that is choice C. What is a possible factored form? Okay, so we're looking at 2 or 3 things really. The roots, the multiplicity at the roots, and the end behavior. So right here, I see a root of negative 2. So that means I know there's a factor of x plus 2, because if when I plug negative 2 in here, negative 2 plus 2 is 0. And I also see the graph bounces off. So I know this one is squared. I see another root at x equals 0. So I could write x minus 0, but that's just x. And this one's to the first power because the graph goes straight through. And I see a third root at positive 1. So that leads to a factor of x minus 1, because when I plug 1 in here, 1 minus 1 is 0. And this graph also goes straight through, so its exponent is 1. So lastly, I need to consider the leading coefficient. So basically, is this positive or negative? Well, I can see the total degree, x to the first times x squared is x cubed times x is x to the fourth. So even degree means that the ends go together, which they do. So the basic even degree is x squared, which looks like this. So since this one is pointing downward, I know it must be the negative version. So I need a negative leading coefficient. So that is choice C. Find all zeros given x minus 1 is a factor. Okay, so I'm going to do synthetic division. If x minus 1 is a factor, that means that positive 1 is a root of it. So I take all the coefficients. So I have 1x to the 5th, positive 1x to the 4th, negative 2x cubed, negative 2x squared, positive 1x, and positive 1 constant. Okay, so let's do the synthetic division. Oh, sorry. This should have been a 2. Okay, so I do get a remainder of 0, which verifies that x minus 1 was a factor. Okay, so, well, all of my choices already knew that positive 1 was a root, so that doesn't really help me eliminate anything yet. But now I want to check, does the root of positive 1 have multiplicity, meaning is it a root more than once? So to do that, I can't go back to the original polynomial because I already know 1 is a root of that. I need to do synthetic division into the reduced polynomial. So I get rid of the remainder because there wasn't one, and now I try dividing into my new polynomial. Oops, positive 1. Okay, so again, I get a remainder of 0, which means that 1 has worked twice, so 1 has multiplicity of at least 2. So let me try a third time. Okay, so this time my remainder is not 0, which means that 1 is not a root for a third time. So 1 has multiplicity 2. So the only choice with that option is letter B. Okay, but what I could do if this wasn't multiple choice, I would go back to the last polynomial that I was able to do successfully, and now I try a different root. So I would try negative 1 next. Okay, so this does work, meaning that negative 1 has multiplicity of at least 1. But now with such a small polynomial, I can actually write it out. Remember, this is remainder, so this is the constant, this is the x term, and this is the x squared term. So at this point, I can just factor it. And I see that x equals negative 1 shows up twice more. So negative 1 has multiplicity 3, and positive 1 had multiplicity 2. Simplify and state all excluded values. So we need a common denominator. So comparing them, 12 versus 6, I need to multiply the 6 by 2 to match the 12, and I have to multiply the numerator also. And then over here, this one is a squared, this has only a, so I need to multiply by a over a. And they both have a single b, so that already matches. So I have 5a minus 8 over my common denominator of 12a squared b. Okay, and then for excluded values, I should have done that in the beginning. If a is 0, 12 times 0 what is 0, and whatever b is times b 0 is also 0. Or if b were 0, no matter what 12a is, 0 times 12a is 0 also. So both a and b are excluded values for 0. So that means the answer is C. Simplify and state excluded values. So we're going to have to do a lot of factoring here. So starting with the numerator on the left. So multiply to negative 24, so one's positive, one's negative. And then the middle term is negative, so I know the negative has a greater absolute value. So this will be minus 6 and plus 4. Okay, denominator, they're both positive, the middle term and the last term, so I know it's plus and plus. So that'd be 4 and 2. Okay, over here we've got a negative constant, so I know that means 1 plus 1 minus. And then because the middle term is negative, I know that the negative has a greater absolute value. And then x squared plus 2x minus 3. So again, negative constant means 1 plus 1 minus. And this time the middle term is positive, so I know the positive number has a greater absolute value. Okay, so I want to check for EVs immediately after factoring. I see that x cannot be -4, x cannot be -2, x cannot be -3, and x can't be +1. Okay, so I've got 4 EVs already. Now I'm going to go ahead and perform the division by multiplying by the reciprocal. So I'm going to flip this second rational function upside down. And I'll just copy the left down. Okay, so now that I have a new denominator, I need to check for EVs again. So these didn't change. -3 was already accounted for, but now I see that x also cannot be +6. And now I look to reduce. They've both got x + 4, both have x + 3, and they both have x - 6. So what's left over is x - 1 over x + 2, and that is choice E. Let's solve. So I need to get a common denominator. So comparing all 3 denominators, I see that this one is missing 3. This one is missing x - 2 in parentheses. And this one already has everything. Okay, so 3x over x - 2 minus, and then 1 times x - 2 is x - 2. Okay, so these go, now the denominators all match. When I distribute these out, they equal 3x - 6. So the most common mistake with this type of problem is not distributing the negative out, or the subtraction. So yes, we get 3x - x, but subtracting -2 turns into +2. Okay, so I'm only writing the numerators at this point because the denominators all match. Remember, you can only do this because it's an equation with an equal sign. You can't do this for expressions. So 2x, and I'll just subtract the 2 over, equals -1, meaning that x equals -1/2, which is choice B. All right, where is the whole? So first I need to factor. Okay, so both 4 and 2 are excluded values, but the 4 sort of gets reduced. So that means that instead of a vertical asymptote at 4, x equals 4, there will be a hole instead. Okay, so I already know the x coordinate of my hole. So the way to get the y coordinate is I substitute that x value into the reduced function. Okay, so 4 plus 3 over 4 minus 2 becomes 7 over 2. So that's choice D. All right, what are the asymptotes? So first, the vertical asymptotes are the excluded values that do not turn into holes. So in this case, x - 3 means when x is +3, the denominator is 0. So that gets rid of these. And then the horizontal asymptote, we need to compare the degrees. Numerator has degree 1, denominator also has degree 1. So that means we divide the leading coefficients. So 2 over 1 is 2. All right, what is the domain? So domain, what x values are allowed. The only reason an x value would not be allowed is if it turns the denominator into 0. So x - 2, x - 3. Okay, so it actually doesn't matter what the numerator is. It doesn't matter if these turn into holes or vertical asymptotes, because either way, it means those x values are not in the domain. So when x is 2, the denominator is 0, and when x is 3. So the domain gets split up at these two numbers, meaning this is the domain. Okay, so we're trying to figure out how long it would take when both Stephanie and Sophia are doing their actions, so the together time is unknown. Stephanie takes 8 hours alone, Sophia takes 10 hours alone, and these two are working against each other, so instead of adding, we subtract, and it always equals 1 whole. Okay, so let's get a common denominator. I'll multiply by 5 over 5 here, and 4 over 4 here. So that becomes 5t minus 4t over 40 equals 1. Multiply both sides by 40. So, and then 5t minus 4t is just 1t equals 40. Simplify. So our denominator is a binomial. There's 2 terms separated by a minus, so we need to multiply by the conjugate, which means switching the sign in the middle. Okay, and we need to remember to put parentheses because we're going to have to distribute everything. So 2 times radical 3 is 2 radical 3. Radical 3 times radical x is radical 3x. 2 times 2 is 4. 2 times radical x is plus 2 radical x. Minus x times 2 is minus 2 radical x. And negative radical x times radical x is negative regular x. So these middle 2 terms cancel out, leaving behind 2 radical 3 plus 3 radical 3x over 4 minus x. And that is choice E. All right, solve. So we always want to get the square root by itself before we do anything else. So first I'll add 4 to both sides. Then I'll divide both sides by that coefficient of 2. Okay, so to get rid of the square root, now that it's by itself, I can go ahead and square both sides. And then subtract 1, and we get x equals 35, which is choice C. All right, simplify 3i over 2 plus I. So again, we need the conjugate, which is the denominator, but with the middle symbol switched. And again, I need to distribute. So 4 minus 2i plus 2i minus I squared. So I squared is negative 1, so negative 3 times negative 1 is plus 3. And negative I squared, negative negative 1 is plus 1. So in the numerator, I have 3 plus 6i. In the denominator, these cancel out, meaning 4 plus 1 is 5. So that's choice C. 15, what's the domain? Okay, so remember for the basic parent square root function, it looks like this. And the main concern is we don't want to square root a negative number. So nothing else really matters except what happens inside the square root. And the square root, or what's inside the square root, it can be exactly 0 or bigger than it, but it can't be negative. Okay, so x can be any number, negative 4 or bigger. So because it can be exactly negative 4, we use the bracket. Right? We can square root 0 itself. Okay, what's the range? So again, the parent square root function looks like this. The vertical stretch won't really affect the range because we were going upwards anyways. The horizontal translation, again, doesn't really affect the range either, but the vertical translation does. This moves the whole graph up, meaning the lowest point we ever get to is the y-intercept of 0, 1. So the lowest y value is 1, and we do hit exactly 1. But then we can go upward forever. All right, simplify. So 162, you could always do a factor tree if you need. Okay, so 162 is equal to 2 times 3 to the 4th. So since I'm doing a cube root, I'm going to use up 3 of them. So that leaves a 2 times 3, that leaves a 6 behind. Okay, so I can take a 3 out to join the 5. 3 times 5 is 15. And then remember, cube root of a negative is fine. It's not imaginary because -1 cubed is still -1, so cube root of -1 is also -1. So the negative just goes outside. There is no I created. So that is D. All right, so before I combine logarithms, I need their coefficients to match. So I'm going to move those coefficients up into the argument. So log 5 of x squared minus log 5 of 2 cubed equals log 5 of 18. And 2 cubed is just 8. Okay, so now to combine two logarithms getting subtracted, I divide their arguments. And then because they're both log base 5, I can just set the arguments equal to each other. Okay, so let's solve for x. Okay, so when we square root, we need to consider both positive and negative roots. But when we go back and plug it in, I can't plug in -12 for x, because then I'm doing log base 5 of -12, and your argument can't be negative. So in this case, only the positive solution works. All right, what's the domain of this exponential function? Well, I can plug any number in for an exponent, right? We know how to do exponents that are positive, that are negative, that are 0. There's no reason we can't do any exponent, so all real numbers. What is the range? Okay, so now the basic parent exponential function looks something like this. It flattens out, but we have a negative a value, meaning it gets reflected over the x-axis. So we can go downward forever, but we flatten out before we ever get to exactly 0. So that would be letter D. All right, what's the domain of a logarithm? So remember, with a logarithm, the concern is we can't have the argument be, or the argument has to be positive. So it can't be exactly 0, it needs to be bigger than 0. So x is greater than 2, meaning 2 to infinity, and we use the parentheses because, again, if we use exactly 2, 2 minus 2 is 0, and 0 can't be your argument. All right, lastly, x-intercept. So the x-intercept is where y equals 0. So I'm going to exponentiate both sides by 7, which cancels this out. 7 to the 0th power is 1. And then subtract 5 from both sides. So when x is -4, y is 0.